2016 Leaving Cert Higher Level Paper 1 Question 9 is a patterns question. You're given this diagram. First stage of a pattern, a point moves from the origin parallel to the x-axis a distance 4. Then it turns left each time, moves up half the distance 2 parallel to the y-axis. Turns left, moves half the distance, I'll put the 2 in, 1 parallel to the x-axis. Turns left, moves half the distance, which will be a half parallel to the y-axis, then a quarter, then an eighth, and so on. So after how many stages has the point completed when the total distance is 7.9375 units? So let's write the pattern out here. 4, 2, 1, a half. You may have seen this pattern before with the fly jumping across the table. So this is a geometric series where we have the first term, a is equal to 4, and my common ratio is term 2 over term 1, which is the same as term 3 over term 2, which you can see in this case it is. So this common ratio is 1 over 2. So the sum of n terms is equal to this, 7.9375, and my formula for sum of n terms is a times 1 minus r to the power of n, and it's the n that we're looking for here, over 1 minus r. So 4 by 1 minus a half to the power of n over 1 minus a half has to be equal to 7.9375. So we just need to simplify this down and isolate our n. So let's remove the bracket first. 4 times 1 minus 4 times 1 over 2 to the power of n. Well, 1 to the power of n is 1, so 1 over 2 to the power of n divided by a half is equal to 7.9375. So we divide a half into both of these, we're going to get 8 minus 8 over 2 to the power of n equals 7.9375. So if I bring the 8 over 2 to the power of n to the right and bring the 7.9375 to the left and take it away from 8, that's going to give me, well, it's going to give me 625, so 0.0625. So these are going to swap places. 2 to the power of n is equal to 8 divided by 0.0625. Typing this into a calculator, it works out evenly. 2 to the power of n is 128, 2 to the power of 5 is 32, 6 is 64, and 7 is 128. N is equal to 7. You could in this case have done trial and error. We had the first 1, 2, 3, 4, 5, 6 terms. You can see that adds up to 7 and a bit, and we were trying to get to 9375. So you could have actually done it with trial and error as well, but I think mathematically is always the best way to do these questions. Part 2, you're asked to find the maximum distance the point can move along its path if it continues the pattern indefinitely. So this is the sum to infinity, so there has to be a limit to how far he can go, and the formula for this is a over 1 minus r. So we had 4 for a, didn't we? 4 over 1 minus a half. It's just going to be equal to 4 over 1 minus a half, which is just 4 divided by a half. Easy enough question, which is equal to 8 units. Part 3 of this question, you're asked to complete this table for the first 9 stages. So we can fill in our zeros first. Every second one is a 0. So fill them in first. And let's have a look at the pattern here. X, the change in x, it's going by a half each time, but it's reversing direction each time it moves on the x-axis or y-axis. So we're multiplying 4 by minus 1 over 4 to get minus 1. So we need to multiply each term by minus 1 over 4. So minus 1, I'll just look at the x's first. Minus 1 times minus 1 over 4 is going to give me 1 over 4. Then I'm going to have 1 over 4 times minus 1 over 4. 1 over 4, which is minus 1 over 16. And then I'm just going to have a 1 over 64. Same pattern exists with the y's. I'll do them in a different color. Same pattern. So we started with a 2 with the y. So 2 by minus 1 over 4 is going to be minus 2 over 4, which is minus a half. So it's going to change signs. It's going to be plus an 8, 1 over 4, and then minus 1 over 32. And you can see the relationship between these guys is a half, or minus a half. So that's the table complete. Next part. So the other half of part 3 is hence or otherwise find the x coordinate and the y coordinate of the final position that the point is approaching. So this is again sum to infinity. If we can actually draw an infinity symbol, it would help. So what's my x? My x started with a movement of 4, and we can see from above that the ratio is minus 1 over 4. So we have a over 1 minus r will give us the x position. So we're going to have 4 over 1 minus 1 over 4, which is 4 over 5 over 4, which is 16 over 5, which is 3.2. For sum to infinity of y, the first movement for y was a 2, and again the ratio is minus 1 over 4. So a over 1 minus r is 2 over 1 minus 1 over 4, which is 2 over 5 over 4, which is going to be 4 times 2, 8 over 5, which is, what's that, 1 3/5, 1.6. So the final position that it's approaching is 3.2, 1.6. In part B of this question, you're told a male bee comes from an unfertilized egg, i.e. it has a female parent but no male parent. I'm confused already. A female bee comes from a fertilized egg, i.e. it has a female and a male parent. And we can actually see this in the diagram here. So the male just has a female parent. The female, following the blue arrows, has a female and a male parent. Female again has a female and a male. The male just has a female. So this female will have to have a female. Just have to fill out generation 5, and it will have a male. I can put it in the box underneath. A male just has a female, and the female has a female and a male. So 5 generations of bees. Part 2 of this question, the number of ancestors of this bee can be calculated using the formula gn plus 2 is equal to gn plus 1 by gn. So that would be g3 is equal to g2 plus g1. Now you may, and if you don't, you should probably, let me write down the numbers up here. We've 1, 1, 2, 3, 5. You may recognize this sequence, and you should recognize this sequence as Fibonacci sequence, where you add the 2 previous numbers. 3 and 2 is 5, 2 and 1 is 3, to get the next number. So 5 and 3 is 8. That's the next number. 8 and 5 is 13. The next number will be 21. 13 and 21 is 34, and so on. We're asked for G6 and G7. So 1, 2, 3, 4, 5, 6 is 8. 7 is 13. And there's a great YouTube video about Fibonacci in nature. So go and check that out if you haven't seen it. The number of ancestors in each generation can also be calculated using this formula. G of n is equal to 1 plus root 5 to the power of n minus 1 minus root 5 to the power of n over 2 to the power of n by root 5. Now we could just go 1 plus root 5. We're asked to find G3, 1 plus root 5 by 1 plus root 5 by 1 plus root 5. But if you're good at binomial expansion, if you're not, go and look at the video on binomial expansion and leave insert algebra. But leaving binomial expansion, when it's to the power of 3, we're looking to the power of 3 here, n is 3. This is going to apply to line 1, 3, 3, 1 from Pascal's triangle to my binomial expansion. So let me do 1 plus root 5 to the power of n. If you're not comfortable doing this, or to the power of 3, you can just do this. It just takes a bit longer. So 1 to the power of 3 plus 1 to the power of 2 by root 5 to the power of 1 plus 1 to the power of 1 by root 5 to the power of 2 plus root 5 to the power of 3. And we add our, by now we have to get these answers and then multiply each term by the corresponding term in Pascal's triangle. So we're going to get 1 plus 3 times root 5 plus 3 times root 5 to be squared, which is 3 times 5, plus 1 times root 5 to be cubed, and root 5 to be cubed is root 5 by root 5. We're going to get 5 root 5. Then if I apply this to 1 minus root 5 to the power of n, I'm going to get 1. And the signs alternate when we have a minus sign when we're doing binomial expansion. So we're going to have 1 minus. And you can see it's going to be the same terms, just with different signs. So we're going to get 1 minus, if you can just do that real quick, you can see we're going to get the same terms. So it's going to be 1 minus 3 root 5 plus 3 times 5 minus 5 root 5. So the first one gives me 1 plus 15 plus 3 root 5 plus 5 root 5. So that's going to give me 16 plus 8 root 5. This one's also going to give me a 16, but it's going to be minus 8 root 5. And we have the first one minus the second one. So this is 16 plus 8 root 5 minus 16 plus 8 root 5. So the top line is going to give me 16 8 root 5. The 16 cancels. 16 root 5s. The bottom line is 2 to the power of n root 5, and we're dealing with 2 to the power of 3 here, so that's 8 root 5. So 2 to the power of n root 5 is equal to 2 to the power of 3 root 5, which is equal to 8 root 5. So the first one over the second one is going to give me 16 over 8, which is equal to 2. In generation 3, Fibonacci, we have a 2. So that's quad erat denum strandum, that which must be demonstrated, and that's the end of this question.